This right here is the crest, and that is the top of the wave. This right here is the trough, and it's the bottom of the wave. This is the amplitude, which is the distance from the midline to the crest or the trough. This is a wavelength, and a wavelength is the distance between any two corresponding points on adjacent waves. This is the nucleus. This is an electron in the ground state, which is the lowest energy level. And this is an electron in an excited state. This being our lowest energy state, we can go ahead and label it this, all the way up to our highest energy state. So once the electron absorbs the photon, it goes up in energy level. Which then produces our red light. So now an electron emitting photon energy goes down in energy level. Which then produces our ultraviolet light. Okay, before we actually fill out the Aufbau diagram, we'll go over some basic rules and principles. The first one is the Aufbau principle, which states that electrons must fill lower energy orbitals before filling higher energy orbitals. So you couldn't just go like that and then put one here. You have to fill the lower one, so like 1s, and then 2s, and then 2p. So then you work your way up. Alright, the next rule is Hund's rule, which says that every orbital in a sublevel must have one electron in it before a second electron can be added. And the square is the sublevel. And so it's pretty much just saying that you can't go like this, and then like this, and then like that. You have to fill your sublevel before moving on to the next. And then the next principle we'll look at is the Pauli exclusion principle, which says that no two electrons can have the same set of 4 quantum numbers, and electrons in the same orbital cannot have the same spin. So pretty much what it's saying is you can't do that and that. That's a violation of the Pauli exclusion principle. So what you need to have is that and that. Okay, now we'll look at the actual properties of the Aufbau diagram. So these numbers on the side are just indicators from the periodic table. So you have your S here, and then you have your P orbitals here, and then you have your D here, and your F here. So now we will actually fill out an Aufbau diagram for sodium. So we'll go here, then move to our next orbital. And then we have 1. Alright, and the quantum numbers is just a set of values that describes the state of an electron, including its distance from the nucleus, the orientation and type of orbital where it is likely to be found, and as well as the spin. Going back to the Pauli exclusion principle, it states that no two electrons in an atom can have the same set of quantum numbers. The principal quantum number is N, is the number of the electron's shell.